BSc Chemistry, Organic Chemistry, SEC Second, Field Chemistry, presented by B. Madhav Narayan. Field chemistry is one of the important parts of chemistry in which I discuss reforming of petroleum. Contents: reforming, definition of reforming and reforming types, technique, schematic view of thermal reforming, schematic view of catalytic reforming, and chemistry of reforming. Reforming. The naphthas derived from the distillation of crude oils are referred to as straight run naphthas. Reforming is a chemical process used to convert petroleum fractions distilled from crude oils, typically having low octane ratings, into high octane liquid products called reformates. Primary object of reforming is to improve anti-knock properties of gasoline. These are premium blending stocks for high octane gasoline. The dehydrogenation also produces significant amounts of byproduct hydrogen gas. Now, what is the definition of reforming? The process of converting low octane linear hydrocarbons, that is paraffins, into branched alkanes, isoparaffins, and cyclonephtenes, which are then partially dehydrogenated to produce high octane aromatic hydrocarbons, is called reforming. Reforming process is carried out either thermally or in presence of suitable catalyst. There are two types of reforming. One, thermal reforming. Second one, catalytic reforming. The techniques involved in reforming. Thermal reforming alters the properties of low-grade naphthas by converting the molecules into those of higher octane number by exposing the materials to high temperatures and pressures. It is carried out in a reactor at 500 to 600 degrees centigrade and 85 atmospheric pressure. The feedstock is straight run gasoline. Gas formation is controlled by quenching, that is rapid cooling. Fractionator removes the residual gas. Catalytic reforming uses a catalyst, usually platinum supported on alumina, to produce a similar result. Mixed with hydrogen, naphtha is heated and passed over pellets of catalyst in the series of reactors under the high pressure, producing high octane gasoline. Temperature maintained at 460 to 530 degrees centigrade and 35 to 50 atmospheric pressure. Thermal reforming schematic view. The straight run gasoline feedback is sent to heater. The heater is maintained at 500 to 600 degrees centigrade and 85 atmospheric pressure. Then it is sent to a quencher where cold oil is sprayed. The quencher is connected to the fractionator where the residual gases enter into the stabilizer and reformed gasoline is obtained. Catalytic reforming schematic view. You observe that here distillation chamber, naphthas filter and catalytic reformer are placed. Crude petroleum is subjected to distillation. The straight run naphtha is passed through naphtha filter. The splitting occurs. Light naphtha gasoline pool separated from heavy naphtha. Heavy naphtha is then sent to catalytic reformer where high octane reformate is obtained. Now, what are the chemical reactions taking place during the catalytic cracking? The different chemical reactions taking place during the catalytic cracking are: one is dehydrogenation. Dehydrogen means removal of hydrogen from hydrocarbons. Cyclohexane on dehydrogenation in presence of suitable catalyst gives benzene. Similarly, methyl cyclohexane on dehydrogenation in presence of suitable catalyst gives toluene. Second type of chemical reaction is dehydrocyclization, that is N-heptane on dehydrogenation gives a cyclic hydrocarbon which on dehydrogenation gives an aromatic compound. N-heptane gives methyl cyclohexane. Finally, on dehydrogenation gives toluene. Next chemical reaction is hydrocracking. N-decane, when it is subjected to hydrogenation in presence of platinum catalyst, N-pentane is obtained. Last step, isomerization. N-hexane on isomerization gives 2-methyl pentane. The hydrogen thus evolved during the catalytic reform is used to hydrogenate alkenes, promote cracking of larger alkane molecules, hydrocracking, and remove sulfur in the feedstock as H2S gas. Chemistry of reforming. There are four major reactions involved during reforming. The dehydrogenation of naphthalene to convert them into aromatics. Example, methyl cyclohexane to toluene. The isomerization of normal paraffins to isoparaffins. Example, N-octane to 2,5-dimethyl hexane, an isoparaffin. The dehydrogenation and aromatization of paraffins to aromatics, commonly called as dehydrocyclization. Example, conversion of N-heptane to toluene. The hydrocracking of paraffins into smaller molecules. Example, cracking of N-heptane into isopentane and ethane. References. For more information, you can refer book P.C. Jain and Jain, Engineering Chemistry, Dhanpat Rai and Sons, New Delhi. You can also refer Britannica.com, Wikipedia, ScienceDirect.com. Thank you.